Electric Roo here. Today I wanted to talk about an old Heathkit SG-8 RF generator. The things that I did a number of modifications to it. I'm going to talk about that. To bring it up to speed here where it can be usable, actually I have a collection of old transistor radios, some other tube radios, and it's great for a little bit of alignment work on them. I figure why not use something old? If you're going to work on old equipment, it's nice to have accurate old equipment to work on it with. As you can see, the frequency counter attached to the front, those are easily available on eBay, relatively cheap. Bought it from China, but it works very well and it's actually accurate as I compared it to some other instruments that I do have. So it's spot on. So you can see you can adjust the dial where you need it and to know that's the frequency that it's at, because these things were notorious, the dials on these old signal generators, whether it was in the right position or not and where you're actually getting the right frequency out of them. So you can see I changed a couple connectors on the front. I put BNC connectors on it, and also there's a switch there on the left. I pulled out a audio output connector there, and I put a switch in there. I'll talk about that in a little bit. So this is the bottom of what the unit I have looks like now. Now you want to go in, and first thing you want to do, of course, is replace the original filter capacitors in a power supply and some of the others. Now I left the ceramic capacitors alone and the resistors alone. The ceramic capacitors have a little bit of a different temperature coefficient on them. I don't know whether it was to compensate depending on how hot the unit was or not, but I left those the same and I replaced all the other capacitors. And you can see in the upper of that picture, on the upper right there, is the power additions that I made, and the transformer there in the bottom for the frequency counter. But let's look at the schematic first of the things that I did, and then we'll go in closer and take a better look of the modifications that I made. Here's the schematic. Now I'll leave a link in the description with a zip file with the schematic and some of the photos that I took. But some of these modifications have been around for a while, and some of them that I did. Now starting out, you can look at positions C and D on the power transformer, where I connected the transformer for the frequency counter and added a 22 ohm resistor in there to provide the 12 volt DC. The frequency counter actually has filtering in it, so there was no need to add anything there. And I replaced the number 47 bulb with a 6.3 volt LED that actually is the same bayonet style bulb, and added a 1 ohm resistor in series with it. And also replaced, of course, the selenium rectifier with a 1N4007 and a 100 ohm resistor. And above that you can see where I replaced the filter capacitors with a couple 33 microfarad 160 volts. Now between point A and B is where I put a regulation circuit just to keep the B plus steady at all times. I used a TL783. You can see with a 1N4007 across the top, and 82 ohm resistor from out to adjust, and the adjustable resistor there, because the manual specifies 78 volt DC on pin 1 of the 12 AU7. So of course, depending on your input voltage, that may change, so you can set it, and I set it about 80 volts on mine, and it will keep it consistent there. Also a 10 microfarad 200 volt capacitor there on the input of that. Now on the right you have where I added a 4.7K resistor across the band A coil to change the Q of that coil. It improves the waveform. And at the top left there, the 12AU7s, you can see where I added a 200 picofarad capacitor and that switch that you saw on the front panel there. What that does is reduces the drive on the 12AU7 to improve the waveform on the lower bands. So you'll be able to switch that in and out. So let's move on to some close-ups of the work that I did, and we'll talk about each thing. Here is a close-up of the top of the unit. You can see where I added the 200 picofarad cap, the black one there, and also the switch to the right in front panel that you saw on the picture of the front panel. And the blue resistor there is that 4.7K that I put across band coil A. And there's a that yellow cap is just one of the older ones that I had replaced in the unit. Here are some of the power supply modifications that I made. You can see I attached the regulator to the case using the case as a heat sink. You can see the bolt there in the middle, and that white that's white insulation tape there because those connections were really close to the case. On the right there you see the adjustable 10K potentiometer there that I put in, and on the bottom terminal strip there there's the 100 ohm resistor and the 1N007 that I substituted for the selenium rectifier that came with this unit. Here's how I mounted the little power transformer for the frequency counter. As you can see, I wanted something small, so I just ripped the transformer out of a wall wart there and made a mounting bracket for it. To the little right of it, you see a little bit of the green original PC board that contained a rectifier sticking up there, and the 22 ohm resistor next to it that I put in there, and that green cap's one of the ones that I had replaced, and also the brown one, one of the ones that needed replaced in that particular unit. As I said, I left those ceramics alone because from the markings it looked like they had a negative temperature coefficient. I'm not sure about that, but I left them in there. Seem to be working fine at this point. Here you can see the simple modification I made to the lamp socket at the 1 ohm resistor there, just to limit the current, because sometimes, depending on the power line voltage, there was a little more than 6.3 volts going to that LED. And up top there's the power feed for the frequency counter going out through it. You can see where I mounted it with actually two screws, one on the left, one on the right. You can see the one on the left there. That frequency counter came with a nice plastic case, so it made it easy to mount to anything you need. Here is the waveform before any of the modifications. You can see it 455 kilohertz there. A picture of what the waveform looked like before any of the modifications were done. So as you can see, I think it needed just a little bit of cleaning up, which the modifications did nicely. And here is a screenshot of the waveform after the modifications were done at 455 kilohertz. As you can see, it cleaned the waveform up real nice. So if you have any comments or suggestions, please do so. Leave it in the comment section and I will respond to you. So other than that, Have a good day.